This is our third method for solving systems. So the first one we did solve by graphing, then we did solve by substitution. In this video we're going to do solving systems by elimination. Sometimes you'll hear it called the addition method. Same thing. So here are your steps for elimination, also known as the addition method. The first thing to keep in mind is that you have to get both equations in standard form. Standard form is this ax plus by equals c, meaning get all your variables to one side, all your constants to the other, and combine up like terms if necessary. Second step is to multiply either the top or bottom or both by some number so that you get one set of coefficients that have equal but opposite numbers. So you'd have 2x and negative 2x, or 7y and negative 7y. Same number, opposite signs. Once you get that, you're going to add the equations, which will eliminate that variable, the one that are equal and opposite. They'll cancel out, give you 0. Then you'll have one variable left, so you're going to solve for that variable, back sub into either equation, will get out your other variable, and then you will always check these. So here's example 1. Now, if I notice the y's already are equal but opposite, they both have a coefficient of 1. One's positive 1, one's negative 1. So I can go ahead and add them because the y's are already equal and opposite and they're in standard form. So when I add component-wise, which means add your x's, add your y's, add your numbers. So I have x plus x gives me 2x. Y minus y, those cancel out, and then I have 13 plus 5, which gives me 18. So with elimination, once you add them, if you've done it right, you will always eliminate one of those variables. So now I solve for x. So I get x equals 9. And then I'm going to take the 9 and back substitute it into the other equation, or to any of the equations. So I can plug in x equals 9 to either equation. It doesn't matter which one. I'm going to plug it into the second one. So I'll have x minus y equals 5. I want to plug in 9. So I'm going to minus 9, get negative y equals negative 4, divide by negative 1, get y equals 4. So my final solution is the 0.94. Now with these, always check them. So I want to make sure both equations work for this point. So I have 9 plus 4 equals 13. I want to know, is that true? And that one is true, so that's good. Check my second one, which says 9 minus y equals 5, and that is true as well. So because it works for both equations, I know that I got it right. So 9, the 0.94 is my answer for that one. Alright, so this one, already in standard form, I have my variables on one side, my coefficients or my not variables on the other. I don't see anything immediately that is equal but opposite. However, if I look at this 2y, 2y, those are equal but not opposite. So I can multiply through by a negative 1 to make them opposite. Now, it doesn't matter which one you multiply. So I'm going to multiply the second one by negative 1, which means I'll have negative 2x will give me positive 2x minus 2y equals positive 4. Now my other one isn't going to change. So that one stays the same. So the only one that changed was my second one, and I just multiplied it through by a negative. I'm ready to do the addition method when I have equal but opposite coefficients. So I can add these. Add them straight down, add them component-wise. So I've got negative 10x plus 2x gives me negative 8x. Those cancel because 2y plus negative 2y, or 2y minus 2y. And then I have 24. I'm going to divide and get x equals negative 3. So that's my first answer. Now my y comes from when I plug x into either of those equations. I'm going to plug it into the bottom one because the numbers are a little bit smaller. So I'm going to take x and I'm going to back sub. So I'll have negative 2x, but x is negative 3, plus 2y equals negative 4. Now it's just a matter of solving. I have 6 plus 2y equals negative 4. Now I'm just solving. So my solution is negative 3, negative 5. So now I'm going to check this. I'm going to plug in x equals negative 3 and y equals negative 5 and make sure both equations are true. I checked it. I got that both equations were true. So negative 3, negative 5 is my solution. So my final example looks a little different because it's not in standard form. And the reason I know it's not in standard form is because I have y equals and 2y equals. And standard form says that you want ax plus by equals c. So that means the first thing I have to do is move over this x and move over this negative 2x. So I'm going to minus x from both sides. So in the first one, I'll have negative x plus y equals 4. And then the second one, I'm going to add 2x, so I will have 2x plus 2y equals 8. Now that I have moved everything over, it's now in standard form, I can set it up to eliminate. I can either pick the x's or the y's to eliminate. It's going to be easier if you pick the ones that are already opposite signs. So notice these x's are already negative x and positive 2x, so that would be pretty easy to make them equal but opposite. I would just multiply the top one through by a 2. I'm going to multiply this whole thing by 2. So it's like distributing, multiply every single term. So my top equation, I'm going to have negative 2x plus 2y equals 8. Make sure you multiply every single thing. And then the bottom one won't change. So now I'm going to add them. The reason I'm going to add them is because I have equal and opposite coefficients. Add them. Negative 2x plus 2x is going to give me 0, cancel. 2y plus 2y gives me 4y equals 16. I'm going to divide by 4, divide by 4. So my first one is y equals 4. Now I'm going to take that and substitute it into either question or the ones that were solved for. Now I see that this top equation, y equals x plus 4, if I plug it in to that one, then it'll be kind of an easier step. I'll just have to move the 4 over. So I'm going to back substitute it in there. And I'll have y equals x plus 4. Well, I know that y is 4. And then I have x. So I'm going to minus 4, and get x equals 0. So my solution is the point 0, 4. Now you got to make sure you check these. So I'm going to plug in x equals 0 and y equals 4 to both equations in the question, make sure it's true, and then I know it's right. So I checked my solution in both equations and I got two true statements. So I know the point 0.04 is the correct answer.